Hello guys, I am Nidhi Bagalwadi, your science teacher Sankalp Learning Solutions. So in the last class we were discussing regarding the lenses, okay? So the lenses are nothing but which will be having two refracting curved surfaces. It might have only one, otherwise two refracting curved surfaces. So those are called as lenses. So we have two types of lenses, as we all know, convex and concave. Today we are going to learn certain terminologies in the lenses because the terms in the lenses are quite different than compared to the spherical mirrors. So we will not use the same terms as we use in a spherical mirrors here. Right. Now here what happens, let me consider a convex lens, a biconvex lens, and let us say a parallel beam of light is incident on the convex mirror and the rays are meeting at a point, so which is called as a principal focus. So this point is considered as a principal focus where all the refracted rays will meet. Okay, so that is a principal focus which will be on the principal axis, and the center of the lens, it is called as a optic center, and which is denoted by letter O. Then principal focus always denoted by capital letter or the uppercase F. Now, so as the lenses will be having two refracting surfaces, so the parallel beam of light might go from the left side. Otherwise, when the parallel beam of light comes from the right side of the of the lens, so the converging rays will meet at the other focus on the other side, left side of the lens. So this side is considered as F2, principal focus 2. Okay, and the distance between the optic center and the principal focus, gives us a focal length. Okay, here I can say OF2 is a focal length, here OF1 is a focal length. Okay, this is regarding the two terms, that is focus and optic center. Then when we go to the other kind, so here this is the optic center, and we know that the lenses will be having two spherical surfaces. One spherical surface will be the part of one circle. Okay. The other spherical surface will be the part of other circle. So obviously, let me correct this. Obviously, we will get two centers here, C1 and C2. So this C1 and C2, practically when it is examined, they are found to be double than the focal length. For example, if OF1 is a focal length, it is of 2 centimeter, then OC1, that is the distance between the optic center and center of that sphere, will be 4 centimeter. That is 2 into twice of the focal length. So instead of writing C1 and C2 in the lenses, we will write these points as 2F1 and here 2F2. So here they will be twice or double than the focal length. This is regarding the centers of curvature of the lenses. The next one is the thickness of a lens. Thickness. Suppose these are the thin lenses. Suppose if we take the thick lens, what happens? For example, what actually happens in the lenses is, so this is a lens. We will incident one ray, that is PQ. Okay, and this is a normal drawn on it. And here it will get refracted, so it will move towards the normal. This is a normal. It will move towards the normal. Then again when it reaches, so here again we will draw the normal, so it will move away from the normal. That is change in the medium. Okay, so when we increase the thickness of a lens, if we take a thicker lens, so what happens there? The parallel beam of, let us take this as an optic center. the parallel beam of light which are traveling, okay, they will also meet at certain point which is called as focus. But the focal length of a thick lens, will be shorter than compared to the focal length of a thin lens. This is a rough diagram, don't take this. The focal length of a thick lens will be shorter than the focal length of a thin lens. So from this we can say that the thickness of a lens, how much thick it is at the middle, the thickness of a convex lens is inversely proportional. Inversely means if this is more, this will be less. If this is less, this will be more. Inversely proportional. Inverse means we have to write the reciprocal. 1 by f. What is f? Focal length. So the thickness of the lens will be inversely proportional to the focal length of the lens. This is regarding the terminologies and certain important point regarding the convex lens. Let us discuss now the image formation by the convex lens. Image formation, right? Yeah. So, image formation. By convex lens. Okay, so let us consider a lens, convex lens, biconvex lens. Okay, let us draw a principal focus. Let us label the optic center as O, and let us consider an object is placed at an infinite distance. Let us consider the object is placed at an infinite distance and it is incidenting a parallel beam of light. So we are getting a parallel beam of light from an object. So object is placed at an infinite distance from the lens. So after refraction, the rays will get converged and meet at a point which is called as principal focus. This is a principal focus. So this is one of the thing when it is passed through the infinite distance. When all the rays are parallel. Now let me take other situation. So here whatever the image is formed, whatever the image is formed at this, it will be diminished. The nature of image will be diminished or smaller in size, and these will be real and it will be inverted image. It will be inverted image. So this is a nature of an image when it is at the infinite position from the convex lens. The image is formed at the F1, that is principal focus. So let us learn regarding many other cases where the position of an object changes and where the position of image will come in the upcoming session. Until that, learn science, observe science. Have a nice day.